Hi guys, it's Ken. I'd like to talk a little bit about propane and propane systems. And specifically, I'm going to try to address the tables, typical pressures, things like that, and the types of materials that we use. So here's a little lesson on that prior to assigning these worksheets. So let's take a look at this. So in item number 4 out of the outline on gas pipe sizing, I've identified propane, and obviously the propane tables all generally have a 6.3. So the number 3 is going to be the indicator for that. They go from A through M. So in the outline here, specifically, I'll hit up in this first one here on the first one on A. So it's 6.3.1 A through B. And I identified on there Schedule 40 metallic pipe between the first and second regulator or stage regulator. So some of that may not have a lot of meaning. So I'd like to spend just a minute and talk about the regulator reduction systems that they use for LP systems. So what I did was I pulled up one of my worksheets, which is the 128 main gas pipe system number 44, and it's for a single stage LP system. And I'm going to go right down to the drawing on this particular one. Now, one thing I want to point out, on a typical LP system that we would have here, so there's obviously LP is liquefied petroleum. So what's going to happen is there's going to be a regulator that is inside of here. So this will be basically the regulator, which will drop it from whatever pressure is here in the tank, and it should be well above, your 10 psi in most cases. I mean, it's more than adequate to supply pressure. It's very dependent, as you guys know. It is very dependent upon the ambient and the consumption rate of fuel out of there. So this is basically what we're going to call kind of my first stage. Essentially, let's call it we can probably identify it as an appliance regulator. Okay. So what is the job of that regulator? Well, the job of that regulator is to drop it down from the tank pressure, which of course this will be your tank pressure, which will be of course vapor. This will be of course liquid. You don't want liquid going through your regulator. So the vapor at whatever pressure that it is, it needs to drop it down to a workable pressure at the outlet of this regulator down to some reasonable level. Typically that number is approximately around anywhere from 11 to 14 inches of water column, which would be very typical of that. Now in my assignments, I've listed the unit supply pressure is 11 inches with an allowable pressure drop that I have identified in there. But that's essentially the way all single stage gas piping systems will typically work, where they will they'll have a tank that'll generally be a very small tank. That tank will normally be maybe 100-pounder. It's really a lot like a gas grill. So if you have a propane grill, that has a single stage regulator. It brings it right down to the immediate appliance pressure at the outlet, which would be, of course, going to the gas valve. So every one of these appliances, they're going to get the 11 to 14 inches depending on the pressure drop in the system. Generally, I'm only going to see this on smaller applications as a general rule. I don't expect to see this on very big systems, but that's essentially single stage systems. All right, let's take a look at the next one. On the second one that you typically deal with this is basically going to be a two-stage system. Now this is by far, there we go. This is by far a much more common application. So here's my liquefied petroleum. This one, of course, is all going to be vapor. there will be a what we call a first stage regulator. That's going to be identified right here. That's at the tank outlet. Now that regulator is typically going to be anywhere from 5 to 10 psi, which would be normal, pretty typical. Most of the time, that's something that we don't generally have to deal a lot with, but I would generally expect the outlet pressure of that to be approximately about 10 psi. I've heard of numbers being 5 psi on some systems, but I think this is way more typical to see it at 10 psi coming outlet of that first stage regulator. So now most of these lines typically are going to be done with copper or what we call semi-rigid copper tubing or copper piping. And essentially that line there will end up being copper as a general rule. And it's a fairly high pressure. So we can allow, most of the time we can accept approximately about a 1 psi pressure drop that would be in that line. So as a general rule, by the time we get to this regulator, which this regulator is going to be what we call a second stage regulator. And that second stage regulator is going to be what has to drop it from kind of let's call it the first stage regulator down to the usable appliance regulator that would be right here. So this one here would be I would typically expect to see approximately anywhere from 11 to 14 inches of water column going into that system. And what this second stage regulator that you guys are looking at right here, normally that's going to be installed right at the outlet of a building. So that's very, very typical in most applications where you're dealing with somebody in a rural area where they have propane appliances. That's very, very normal. So you've got the first stage regulator out here, you've got the second stage regulator right here, and of course we're down to a usable tank pressure. So how does this relate to sizing? So I think to some extent related to the sizing, I would see that we'd have to kind of identify or understand that every time that we have another reduction in pressure, that we have to start a new sizing program or problem. So in this particular case, when I look at this regulator, I see this as specifically, we'll hit this one up. When I look at this one here from the first stage to the second stage, this section here is going to be sized as kind of as one system that contains all of the gas flow needed by everything on this side, everything. So which would make sense because this is my source way out here. So that would be logical. And that's normally going to be copper. And I'm going to show you the tables and it'll make sense. It's really going to be between the first and second stage. And then the sizing on the outlet side of the secondary regulator or the second regulator at the household or the building, that's typically going to be from this point. So now you're going to leave this one and you'll size it just like you do a natural gas system, except you have to make sure you use the right fuel is typical how that's going to work. All right, so a little bit on that. So we're going to take a look at the tables to begin with at 6.31 A and B, and we'll talk a little bit about that. And now hopefully that makes a little bit more sense when we talk about between the first and second stage regulator. So let's go back to the code book. So on this one, in my code book, I'm on table 6.3.1A. Now this one, I want to point this out, that make sure you note that the Schedule 40 metallic pipe is the piping materials. So when we talk about sizing between a first stage high pressure regulator and a second stage regulator, it is not very typical for me to use that table, simply because most of those applications that I run into are going to have this line buried in the ground. So that's probably not one you'll see used a lot. But it's not that it's not possible, it's just that it's unlikely. So let's go to let's take a look at B. So you'll notice on B, really the only thing that they changed in this case was the pressure drop. So you'll notice that this one, they have a 1 psi drop. The second table on B is a 3 psi drop. You just have to figure out what's the allowed pressure drop. So the more pressure drop, the more capacity is generally accepted or allowed into the system. So let's take a look at this next table. So on the next setup that we have here at 6.31, and I'm going to look at C in this case. Here they're showing a Schedule 40 metallic pipe on this one. Now this one is saying it's used when on a network with a 2 psi service. So let's hit up a little bit on that and exactly what that means. So in this particular case here, if let's say that we're going to pipe it between a 2 psi system and then the line regulator that would be put at the appliance. So this is kind of a high pressure Schedule 40 metallic piping system. And whoops, let's get that highlighter on. So the Schedule 40 metallic pipe, a 2 psi system with a 1 psi drop. I could see this as a very viable option for a customer that wanted to run a 2 psi system. One of the things that I want to point out here is that's different from natural gas that is probably worth noting is notice how the capacity is now in thousands of BTUs per hour. So that might be worth noting. There is no more divide this by the heating content when you don't have to do that for propane. All right. The other thing that it's worth noting here is look at the incredible amount of thousands of BTUs of these systems. So even on a 1/2-inch line on a 2 psi system, I mean, you can be at 500 feet of length here, you could be dealing with 322,000, or let's take a more realistic number at, let's say, at 80 to 100. You're already talking 770,000 BTUs on a 1/2-inch line. So the capacity is really incredible. Again, on a 2 psi, which would be considered like a hybrid type system, that's where this would be applicable for propane. So let's move on to another table. So back to my outline on here. So let's take a look at this next one. And this next particular one is item number C, which would be table 6.31D. And this is Sched 40 metallic pipe, and it's between the second stage regulator and the appliance. And I put a note in here that it's really very typical. You'd use this table for a lot of your propane systems inside a building. Very, very common. So let's go back to that table D. So on the code book, table D, you'll notice that you'll see this on here that they have, I do this every time. They do this at inlet undiluted propane. Inlet pressure is 11 inches. And it's essentially a 1/2 inch pressure drop, 0.5 inches. So this is a very, very typical application. So think of this as you've piped up fuel to your second stage regulator from the tank, you're bringing it directly into the building, and you're running everything at your typical propane values, or is your typical application here. So sizing between the single or second stage regulator. So this would be the table I could also see used for a 1-stage regulator type system. So when you had when the tank dropped it directly from the tank pressure on a single stage system to the appliance pressure, I could see that where this would be applicable as well. So in this case, again, you just have to recognize here's the usage, here's the intended use, very, very helpful, just so you understand that. And of course, all the other things, capacities in thousands of BTUs per hour, it should be all good to go in here. So I think that makes a lot of sense on that one, or at least it should. Okay, let's take a look at the next one. So on this next one, we're going to take a look at item number D. And that says for the tables, 6.3.1E, it's what they're calling semi-rigid copper tubing. So this would be if I'm going to use soft copper piping systems, most likely, again, between the first and second stage regulator. And this would be a very, very typical application, very common. You just have to make sure you understand the materials and things like that. So I made notes of this here for you that, you have either type K or L, and that's kind of plumbing grade, and then ACR, which is your refrigeration type grade. And again, it's the same, really almost the same copper tubing as far as from a physical nature, other than the fact that ACR is cleaner than the plumbing grade typically, but that's the expected number. You just have to know what you're doing with them. So let's take a look at the table. So 6.3.1E. All right. So on 6.3.1E, what I want to do is this. So in the code book, I'm going to highlight a couple things. So here's undiluted propane. Make sure you're using the right fuel. But notice the pressure. So typical what I told you earlier, I said the inlet pressure coming from the tank to the second stage regulator is normally about 10 psi. And the allowed pressure drop is normally going to be about 1 psi. So this is a really very common application for your propane jobs. The tubing between, again, intended use, they have that identified in here very nicely. Semi-rigid copper tubing, and you'll notice how on here they listed type K and L, and they also listed ACR. So you'll notice when you look at these numbers on here, you'll see that the 3/8 and 1/2 inch. So if it's listed as K and L, the K and L and the 1/2 inch ACR have the same physical dimensions, other than depending on whether it's K or L, but it's really similar copper. Again, you'll learn more about that as we go along. And then it's a matter of just, you figure out what your length is, whatever sizing method you want to use. You identify what your capacity requirement is, and you size your piping depending on whether you use the branch length method or you use the longest length method. And that's typical. Now, it is very, very normal, because you're dealing with a 10 psi system right here at the inlet pressure of 10, that you typically are only going to be feeding one regulator. It would be highly unlikely to see it any other way. So that's kind of the normal. But there again, you can get a whole lot of capacity on a system with, with a relative, reasonable length. Most buildings or most customers aren't going to have their tank located, significant distances away from their buildings. So most of the time, you can get away with a 3/8 to a 1/2 inch line without any problems whatsoever. So, but there again, that's a very, very common table. All right, let's take a look at this next one. So there are regulator systems, and I'm going to go back to this number 44 worksheet, and I want to show you this. So there are systems where they will run all these lines directly from this tank on a single stage system, and every one of these lines could be done in copper. And they will do that simply because a lot of times they're fairly small, short systems. They don't need a lot of length. So in those situations, this is going to be, what I would say is going to be a very typical table that we'll be using. There we go. So in this particular case, semi-rigid copper tubing, we're going to be dealing with undiluted propane. It's 11 inches, which would be the pressure coming out of the regulator, feeding the line, 1/2 inch pressure drop. So again, you just identify the usage, make sure you understand what this means, and you need to know your capacities in thousands of BTUs per hour. So let's say you had a system that was 30 feet long, and as far as your length of your, let's say your longest length, you just follow the capacities. So in other words, hey, this is going to need, you could get you have a capacity of 104,000 BTUs if you were to use a, let's say, a 5/8 inch ACR line. So, but that's, again, that's what you typically would see used, is some sort of it's generally a smaller system as a general rule. And you'll see a fair amount of existing jobs that are done that way. So most people nowadays, if they're going to be piping it, they probably won't do those systems that way in copper. I'm not a real big fan of it, just from the rigidity nature of that. So, and that's primarily the way I like to do that. It would be probably more reasonable even for a person to use a CSST type system. So they might use corrugated stainless steel tubing, and then they will, it's just a little bit easier, a little bit faster sometimes to run, and it doesn't kink as easily. So there's some advantages to some of these. So it just depends on the contractor, what they like to do. All right. And I guess just a note on there, the remaining tables that are listed in there, it's really very similar, just different types of piping. So you just have to understand the general concept of exactly what it is that we're doing for a propane system to function, to whether it's a single stage system or whether it's a two-stage system. So